In 7.5, it teaches us two new formulas right here. So first, let's prove the second one, which says cosine of alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. But before starting, it's important to remember that on a unit circle, cosine of theta is equal to x and sine of theta is equal to y, the y coordinate, on a unit circle, because the radius is 1. So in this formula, there's two angles represented by alpha and beta. Now we can draw a unit circle and draw the angles in standard position. So if we can say this is beta, and we can say this is alpha. We can label the point on the terminal side of beta, point 1, and the other on the terminal side of alpha, point 2. And for point 1, because we know this, the coordinates are going to be cosine beta sine beta, and then for point 2, cosine alpha sine alpha. Also, the angle between this terminal side and this terminal side is going to be equal to alpha minus beta. Now we can place the angle alpha minus beta into standard position. So if we draw another unit circle, this is one side and this is the other side. And we can label this as point 3. And since it lies on the terminal side of alpha minus beta, the point's coordinates are going to be cosine alpha minus beta, and then sine of alpha minus beta. And then this side, which we can label just A, is going to be 1, 0, because it's on the unit circle. Now, if we make these two into triangles, and if we can just redraw them right here, we can also see that these two triangles are going to be congruent. So both of the triangles have the same angle of alpha minus beta, and each have two sides equal to the radius, which is 1. So right here and here, and here. So therefore, the triangles are congruent by side angle side. Therefore, these sides are also congruent by CPCCC. Since they're congruent, we can set their distances equal to each other. To remember distance formula, distance for this side is this, and the distance for this side is this. Now let's substitute the distance formula with our coordinates. So we can cancel out the square root by squaring one side. And whatever we do to one side, we have to do to the other. So now both square roots are canceled out. Then we can expand our squared terms. And remember that a plus b squared is equal to a squared plus 2ab plus b squared. Now let's look at our squared terms with the same angle. For example, on the left side, we have cosine squared of alpha minus beta and sine squared of alpha minus beta. By the Pythagorean identity, cosine squared of an angle plus sine squared of that same angle is equal to 1. So both of these, when added, equal 1. So we can substitute that in on this side. And same on this side. We have cosine squared beta and sine squared beta, and also cosine squared alpha and sine squared alpha. So 1 minus. So again, this became this, these two became this, and this one became this one. And now if we combine these two 2's, they cancel out, and we can see that each term in this equation is divisible by -2, so we can divide each side by that. And after simplifying, we get our formula. For our other formula, this one, cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. We can just make beta negative because a negative and a negative make a positive. Now we can just substitute the rest of the formula with negative beta. So because the cosine, so if we remember the even and odd identities, because the cosine function is even, that means cosine of negative theta is equal to cosine theta, because it's even. And then sine of negative theta is equal to negative sine of theta, because it's odd. So if we apply these even and odd identities, we get and this is our other formula. Cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta.